Here at the University of Technology in Sydney, we've set up a Materials and Technology for Energy Efficiency Research Strength, or MTEE as we refer to it. And the whole purpose of that research strength, which sits within the Faculty of Science, is to really bring together researchers from the School of Physics and Advanced Materials to work together. It's all about collaboration and trying to get a lot of very excellent researchers to build their research strengths by collaborating with each other and building a really strong research environment. Within our research strength, there are particular research areas that I think are very exciting. One is led by Dr. Igor Aranovich, and his whole research is around the use of nanodiamonds in a variety of applications, from biological sensing through to computer chips and all sorts of next generation electronic devices. The sort of work he's doing and its implications are very, very broad and really very exciting.
My area expertise is semiconductors, nanophotonics, and particularly diamond nanophotonics and everything that has to do with nanodiamonds. We're trying to look at small nanocrystals, nanodiamonds, and to find if they can be used for drug deliveries and for any other biolabeling systems. Using nanodiamonds to monitor the drug delivery using their fluorescent or optical properties, we're going to attach the chemical to the nanodiamond or to the scene to the nanodiamond and monitor and track it, how it goes around in the body. So there are products that are already doing similar job, but nanodiamonds will offer two main advantages. One is their absolute photostability; they will not be suffering from blinking or bleaching. And the second one is their biocompatibility. So they're currently nothing that is biocompatible, made fully of carbon, which our body accepts without any side effects. Nanodiamonds can really change the world, and there's a great motivation from the students, there's a great support from the deans and from the head of school and from the other people in the group to promote this idea and to promote this research.
The key element of our research strength is the people within it, and we have a number of world-class researchers within that group that are doing absolutely cutting-edge research. What attracts those people to UTS in the first place and what enables them to do a lot of this excellent research are the facilities that they have available to them at UTS, and the facilities particularly within our electron microscope unit. Professor Miloš Toth is probably one of the youngest research professors at UTS. He joined us from an industry perspective, and his whole research is about developing the next generation of electron microscopy techniques.
The electron beam chemistry group is a research group at UTS that's focused on nanofabrication. So we focus on using electron microscopes to fabricate materials with a very high degree of precision. So to do this work, we need to use state-of-the-art electron microscopes, such as those made by a company called FEI in the United States, which is a company I worked for just before I joined UTS, and I was able to bring this technology over to UTS. Now, part of the work that we do here and that our students are focused on is involved with improving these technologies and making them capable of doing things like 3D printing. For new students coming to a facility like the microstructural analysis unit, a great opportunity is that they learn to use all the equipment in here hands-on. They do not just take notes and watch people and become theoretical operators of the equipment, but they get hands-on experience and can go out into the workforce and say confidently, I know how to do this stuff.
Our overall goal is to develop new materials for energy-efficient lighting and other applications like solar cells. And to actually develop those ideas into working technologies, you need to assemble the right team with a range of complementary skills. Australia is pretty far away from the rest of the world and the rest of the scientific community. So if you're based in Australia, it's really important to have external collaborations, particularly with researchers overseas. So that's another of our strengths here at UTS, because most of the members of staff have strong links with overseas institutions. So we have links with researchers at Harvard, Smithsonian, at Oxford University, at various other institutions in the US and Europe. So that's another strength of this research group.
The great thing about UTS is the collaborative and group mentality here, especially in the physics department. Students are encouraged to work together as part of a team. At the facilities level, everybody has access to all the facilities down here, so people can do things from making materials to making devices and characterizing them, studying them here, all in one centralized facility. and they can collaborate with both academic staff and fellow students in wider groups.
We're a cutting-edge research institute. We have cutting-edge researchers, cutting-edge facilities, but the future for us is very exciting. We have a lot of young researchers joining us, and we're creating a very vibrant and exciting research culture.